Hello class, in this video I will be using Lagrange multipliers to find the maximum of a function subject to a constraint. Let's begin. Alright, so we want to maximize f is equal to x times y squared subject to the constraint x plus 2y is equal to 15. So the first thing that we want to do is we want to work with the constraint. So that way we can create the function g of xy is equal to 0. So right now we have x plus 2y is equal to 15, and if I subtract 15 from both sides, I now have a function that equals 0. So I can conclude that g of xy is equal to this expression. Okay, step 2 is to create the Lagrange function. All right, so the Lagrange function is equal to x times y squared minus lambda times the quantity x plus 2y minus 15. And if we distribute the lambda, there's the Lagrange function. The third step is to take all first-order partial derivatives of the Lagrange function. So here we go. All right, step 4 is to set all first-order partial derivatives equal to 0. And the last step is to solve. So we're going to solve the system by solving for lambda in the first two equations. All right, so here are the first two equations. And y squared minus lambda is equal to 0 implies that lambda is equal to y squared. And the second equation implies that lambda is equal to x times y. And since lambda is equal to both y squared and to x times y, it follows that y squared is equal to x times y. And to solve for x and y, I'm going to start by subtracting xy from both sides, and then factoring out a y. So this expression implies that y is equal to 0, or y minus x is equal to 0, which will imply that y is equal to x. Okay. So if y is equal to 0, that's going to imply that x is equal to 15. And that's because if I were to substitute 0 in for y, the result is x is equal to 15. If x is equal to y, we have to do a little bit more work. So we're going to substitute x in for y into the third equation. So here's the third equation. We're going to substitute x in for y, And after solving that equation, it will follow that x is equal to 5. And since x is equal to y, they're the same value, that implies that y is also equal to 5. Now we have two ordered pairs to test. So we need to test 15, 0 and 5, 5. So here, I'm going to create a little bit of room by shrinking this a little bit. Okay, so now we're going to test 15, 0. So f of 15, 0 is 15 times 0 squared, which is equal to 0. Next, we're going to test 5, 5. So f of 5, 5 is equal to 5 times 5 squared, which is equal to 5 times 25, which is equal to 125. So f of xy is a maximum, f of xy has a maximum value of 125 when x is equal to 5 and y is equal to 5. And we are done.